GE142 Curved and Earthworks Module 9 Mass Hull Diagram. So for this lesson, we will be discussing mass hull diagram and how to approximate volumes of earthworks using the mass hull diagram. By the end of this module, you should be able to understand what is mass hull diagram and to learn how to approximate volume or compute volumes of earthwork using mass hull diagram method. So mass hull diagram or mass hull curve shows the cumulative volumes in cubic meter in every station along the center line. So the diagram is useful in planning the haulage of large volumes or finding the overhaul charge of earthworks for linear construction projects such as highways. So if you have a land cross section of land that is not that is irregular, so for example gagawa ng daan or magko-construct ng road on this grade, so ganito. Okay, so this part here will be the cut section and this is the fill section and cut section. So mass hull diagram shows that in every station, say 0. So pinapakita niya yung volume in every station. Kung ano yung volume ng soil na to, dito na part, and also in other stations. So first, we will define some terms before we proceed to the problem solving. So bulking, it is an increase in volume of earthwork after excavation. So usually, siguro nakatry kayo mag-excavate sa bahay niyo ng soil. So pag na excavate yung soil is nagbo-bulk siya. So lumalaki yung volume ng soil. So next is shrinkage. So it is the opposite. So it is the decrease in volume of earthwork after deposition or compaction. So pag kinumpak mo naman yung soil, liliit yung volume niya or that is called shrinkage. Hull distance. It's the distance from the working phase of the excavation to the tipping point. So it is the distance where you hull or you get a soil from a source and to the tipping point, yung paglalagyan ng soil. Average hull distance, it is the distance from the center of gravity of the cutting to the center of the gravity of filling. So same lang sila. Free hull distance, it is the distance over which the cost of hauling will justify the amount of earth to be bought. So it is important to determine yung free hull distance. So para alam mo kung hanggang saan yung limit ng distance, kasi hindi naman pwede na sa malayo ka kukuha ng soil kasi that that will be costly. So in hauling earth material, you will also consider computations on distances para mas economical yung magiging project or yung pag-haul ng soils. Next is overhaul distance. It is the extra distance of transport of earthwork volume beyond the free haul distance. So haul is the sum of the product of each load by its haul distance. So this must equal the total volume of excavation multiplied by the average haul distance. Overhaul is the products of volumes by their respective overhaul distance. Excess payments will depend on overhaul. So borrow is the volume of material bought into a section due to deficiency. And waste is the volume of material taken from a section due to excess. So for example, in this cross section, so meron kang cut and fill. This is cut and this is fill. So for example, at this station is yung volume na to, if you-fill mo dito, dyan yung hanggang dito lang yung na-fill niya. So this will be this section will need another soil. So magbaborrow ka ng soil to fill this kasi yung itong section na to is nagamit na siya until dito lang. So kulang pa ng soil na i-fill dito. So you'll have to borrow from a distance or somewhere na magiging source ng earth material. So yan yung borrow. So for example naman, if you have this section, so in this part, if the volume na i-fill is hanggang dito lang sa cut. So then ito is hindi na siya kailangan. So ito yung magiging waste na material. So what are the characteristics of a mass hull diagram? So first is rising or upward sloping sections of the mass curve indicates that excavation is dominant, thus the contractor has more earth material. So here, so in this part, this section is yung earth material. So yung excavation. So for example, ito yung magiging grade nung daan. So ikakat mo ito na section and if you fill dito na section. So meaning in this part meron ka ng free hull. So hindi ka na mag-acquire or magkukuha pa ng soil from other location just to fill the section here. So you have to use this soil para i-fill dito and ito na lang yung kulang na soil. So that is also reflects the negative or yung sa baba na sa curve. So meaning ito yung kailangan na soil to fill these areas. Next is falling down sloping sections indicates that there are less excavation going on or more areas to be filled. Thus, the contractor has less earth material. So I was saying kanina, this section means na kailangan ng another earth material. Next is the difference in ordinates between any 2 points indicates the net cumulative volume. So mamaya explain yung through a problem. So next is any horizontal line drawn to intersect 2 points within the same curve indicates a balanced excavation or cut and embankment fee or fill quantities between the two stations. So this is the balance. So this dito nagbabalance out yung excavation and fill. So meaning hanggang dito lang yung na-fill na material. So the remaining part here is yun nga kanina kailangan ng another material to fill. So the highest or lowest point of the curve of the mass hull diagram represents points where the proposed roadway coincides with the natural ground level. It also represents points where the roadway goes from cut to fill and vice versa. So itong mga points na to. So this is the point located dun sa level nung magiging highway. And this is also yung changing point. So that is from cut to fill, then from fill to cut. So yun. So this is cut. So if you fill na naman dito. So this is also cut. Na if you fill dito. Okay, so let's define some variables and formulas. So overhaul distance, which is the distance between the centroids less the free hull distance. So that is overhaul distance is the average hull distance minus the free hull distance. So meaning free hull distance is yung as you can see the diagram kanina, that is where the cut section will fit the fill section. So hanggang doon lang yung free hull distance. And beyond that section, that is over hull distance, meaning you'll have to get soil to fill that part. So limits of economic hull. So when hauling over long distances, it may be more economical to waste material from the excavation and to borrow from a location within the free hull limit. So saying, i-consider pa rin yung economical aspects. So even though say for example from a point and you need to fill something here at point here, so even though malaki yung soil na nandito nakatambak dito, but the distance is masyadong malayo, so hindi siya economical. So maybe somewhere here merong another soil to fill this part here. So L is the overhaul distance in meters. So CH is cost per cubic meter of overhaul, and CB is the cost per cubic meter of borrow or excavation. So note that the cost of disposing waste material is considered here as free, of course. So the cost for moving 1 cubic meter of material from cut to fill is given as cost of haul is cost of borrow plus overhaul distance times the cost of cubic meter of overhaul. Whereas the cost to cut then waste the material and then borrow and fill another material from different sources is estimated as cost waste or borrow is equals to 2 times the cost per cubic meter of borrow or excavation, or twice the cost of borrow or excavation. So yun yung cost in cutting and waste the material. So of course, within the limits of economic haul, the cost of hauling justifies the cost of buying from a source or borrow, or throwing the materials away or wasting it away. So hence cost of haul is equals to cost of waste or borrow. So CB plus LCH equals to CB. So this will give us na the length of overhaul is the ratio between the cost of borrow and cost of overhaul. So since the overhaul distance L is measured beyond free haul distance, the limits of economic haul here is given as, so ito yung limits of economic haul. So that is limit of economic haul is free haul distance plus the overhaul distance. So beyond that, hindi na siya economical. So i-substitute lang yung value. So the cost of haul, CH, is often expressed as cost per meter station. Simply multiply the length of each station and the formula becomes like this. So ito na yung formula ng limits of economic haul, where LEH is limits of economic haul, free haul distance, length of each station. So that is usually in meters, that is 20 meters sa metric na measurements. Okay, so para mas maintindihan natin yung problem, let's have some yung concept, let's have some example. Okay, so volumes of cut and fill along a length of proposed road are as follows. So stations from 0, 20, 40, 60 hanggang to 40 meters. So you can say that the length of the proposed road is 240 meters divided into stations by 20 meters. So the volume of soil to cut or either cut or fill is provided. So from 0 to 20, volume to cut is 8.2 meters, 8.2 cubic meters, 21.5 cubic meters, 25 cubic meters, 18.3, 3.4. Then 100 to 120 is cut fill. So 3.3, 9.8, 18.2. So siguro yung road natin is parang ganito siya. So parang ganito. So magka-cut ka and then mag-fill. So determine natin yung mga distances na economical. So first is draw the mass diagram and determine the overhaul if the free haul distance is 80 meters. So first is, before we draw the mass diagram, we will calculate first the cumulative volume for each station. So note that cut is considered positive while fill is negative. So cumulative. So to find the cumulative volume, so we simply add the volumes dun sa preceding stations, considering na positive yung cut and negative yung fill. So at station 0, so of course 0 pa yung volume dyan. So 0 to 20, meron tayong 8.2 cubic meters. Then 20 to 40, 0 to 40, meron ng 8.2 plus 20, 21.5, so that is 29.7. So ito yung 0 to 40 na volume. So continue the process. So i-add mo lang siya. So hanggang magiging negative 16.6. So meaning hanggang somewhere between 220 to 240, nag-end doon yung free haul distance. So may compute natin. So to create the mass diagram, plot the stations versus the cumulative volume in length. Okay, so meron na tayong mga cumulative volume per station. Okay, so we'll plot the cumulative volumes. So at station 20, meron tayong 8.2. So somewhere here. And then at 40, 29.7. And then 54.7, 73, 76.4, 73.1, 63.3, 45.1, 20.1, 1.0, negative 13.2, and negative 16.6. So we'll connect the dots or the points. So balance point is almost at the 200 station. So using graphical method is faster kasi i-graph mo lang siya and scale or estimates yung mga distances, but it is also less accurate. So we are given with a free haul distance of 80 meters. So if we have a ruler, we will place the ruler and measure 80 meters from the highest point of the curve. So maybe somewhere here yung 80. Change natin yung kulay. So I think somewhere dito. So that is so we'll assign this point as A and this is B. So if we will project this pababa, this will be A prime, and also this will be B prime. So B prime is approximately 64. And B prime is also approximately 140. So 140, 144. So free hull distance na 80 meters. So approximately 80 meters yung distance na to. So if you have a ruler, mas madali yung pag-graph natin. Okay, so we'll assign letters to every point. So say this is C and this is D. So A, B, C, D. So the balance point. So somewhere here yung D natin, that is the balance point. Okay, so to find the overhaul, bisect line CA prime and draw a vertical line. So we'll bisect C and A prime. So since A prime is somewhere in 64, so half of 64 is 38. So somewhere dito. So we'll project this is approximately 38. So project a vertical line pataas. So we'll assign this point as letter E. So at this point E, we will project another horizontal line papunta sa kabilang point. So we will assign this point as F. Okay. So these points represents the centroid of masses. So i-project natin ito pababa. So this is approximately 172. So by inspection, points E and F are approximately 38 and 172 on the graph. So from this, the average hull distance is approximately, so the average hull distance is approximately equal to 172 minus 38. So this is equals to 134 meters. So this is the average hull distance from E to F. Since this is the centroid of the cut and fill. So the overhaul distance is then obtained from the formula. So meron tayong overhaul distance is equals to average hull distance minus the free hull distance, which is yung 80 meters. So this is 134 meters minus 80 meters. So overhaul distance is equals to 54 meters. So to obtain the volume of earthworks, we simply get the difference in ordinates of mass curve. So to get the overhaul of material, we can just consider AA prime, since by principle CAA prime is to be hauled to DBB. Okay, so it means that since this is the free hull distance, so cut and fill is equal dito na part. So if you cut this section here, the CAA prime, that is to be filled dito na section sa BB prime BB prime D. So yan yung overhaul distance natin. So to compute the volume, so overhaul is equals to the volume AA prime multiplied by the overhaul distance. So by inspection, so at this point, the approximate volume here is 60 cubic meters. So approximately yung volume na to. So since as we were saying, the graph shows the cumulative volume on each station or on each distance. So the volume here, dito na part is approximately 60 cubic meters. So this is 60 multiplied by the overhaul distance na 54. So the overhaul is approximately 3,240 cubic meter. So that is approximately 3,240 cubic meter. So yan yung overhaul natin. So ito na yung multiply yung cost ng overhaul. So that is the volume of soil na i-overhaul natin beyond the freehaul distance papunta dito sa section na to. So that is where it balances then. So this section, so another, magbaborrow ka na to fill this section kasi yung resources mo dun sa distance 240 is na-fill na hanggang dito sa 200 meter station. So you need to borrow soil. So this is where the case where you'll have to borrow. So to fill this area, you'll need to borrow a soil. So ang volume ng area na to is 16 cubic meters. Also, there is another way of obtaining overhaul, that is by analytical method. Analytical method by taking moments. So say for example, if this is an area, sa statics natin, you get the area by taking specific area by taking moments. So ito yung apply natin dito sa problem na to. So using analytical method. So with reference to the mass Hall diagram drawn and the tabulated cumulative volumes, moments are taken at C to find the centroid of area CA A prime. So from moments galing dito. So the cumulative volume from 0 to 20 hanggang 64. So hanggang 64 lang is 60 cubic meter. So hanggang dyan lang. So yung cumulative volume. So note that the difference in ordinate corresponds to the volume of earthwork within the region. So the distance column in the table below are the approximate values of the centroidal distance of each region from the reference point C. So from station 0 to 20, volume is 8.2, so the distance is 1/2 20 plus 0, so that is 10. 1/2 the distance 40 plus 60, that is 30, 50, and then 62. So you multiply the volume doon sa distance. So makuha tayo ng product of 82. So that is volume times distance. So the summation of volume times distance is 2,305.6, and the summation of volume is 60 cubic meters. So the distance from the C to the centroid of mass CAA is 38. So i-divide natin yung dalawa. So that is 38.4 meters. So using this analytical method, mas accurate siya. So kanina, in-estimate lang natin yung midpoint from C to A prime is 38 yung in-estimate natin. So but using analytical method, mas accurate na siya. So that is 38.4. So that is where point E is projected. So this is 38.4. Okay. So for the other side, yung sa kabila, so also do the same with mass dBB prime. So note that B prime is at station 144 from the mass curve. So yun yung if you nag-project tayo nung B Yung B natin pababa, that is B prime. So located somewhere at 144. So from 144 to 160, the volume is 60 minus 45.1. So that is 14.9. So 160 to 180 is 25. And 180 to 200 is 19.1. So the distance, so same, 1/2 of 144 plus 160, so 152, 170, and 190. So also we'll get the product of the volume and the distance. So we will neglect the remaining area to the balance point since it is very small. So that is somewhere 16 cubic meters lang. So summation of V and summation of V times D. So i-divide natin. So the distance from C to the center of mass DBB is 171.9 cubic meters. So yung kanina 172 yung na-approximate natin. So therefore, ulitin natin yung formula. Overhaul distance is equals to the difference between the 2 points. That is 171.9 minus 38.2. So 133.5 meters. So yung kanina, 134 yung average haul distance natin. This is average haul distance. So repeating the process, overhaul distance is average haul distance minus free haul distance. So overhaul distance natin is 53.5 meters. So yung kanina, meron tayong 54. So merong difference na 0.5 meters. So to get the volume, to get the overhaul, so we multiply the volume by the overhaul distance. So meron tayong overhaul na 3,210 cubic meters. So yung kanina, meron tayong 3,240. So may difference na 30 cubic meters. So though analytical method is complicated, but it has a format nung process. And also it is accurate. Okay, so that's it. So this is the end for module 9, and I hope you understand the explanation. So medyo dinalian natin kasi behind na medyo short yung time natin this semester. So thank you for listening and have a good day. So you can watch or outsource some references para mas maintindihan ninyo. So thank you for listening and have a good day.